Hey guys, welcome back. This is the second out of 3 installments of the math portion of the ATI study group. Again, I hope that we can get through this, and let me get my tablet up and running and then we'll start. Okay. Oh my gosh. Oh, there we go. Oh, look, my tablet joined the meeting. How thoughtful. So excited. Okay. Sorry, guys. I promise I'm not crazy. Just only on days that end in Y. Okay. So, picking up where we left off, solving real-world problems involving percentages. So that can either be percentage decrease or an increase. There's a really complex way to figure out the percentage decrease and increase. The negative difference between 2 numbers divided by the first number multiplied by 100, and then positive increase is the difference between 2 numbers divided by the first number multiplied by 100. The whole point and purpose of these questions is that you need to be able to define the percent in terms of real-world numbers, calculating the percent of a number in the terms of real-world context, and finding percent of increase or decrease between 2 numbers in terms of a real-world content. So let's move on. Again, I hope you have your piece of paper and your pencil handy. So write these down, because when I switch over to my whiteboard, you won't be able to see this. Your current salary is $50,000. Next year, you'll get a 4% increase in your salary. How much money will you make next year? Which of the following is 25% of 680 pounds? A, 1,700, B, 510, C, 68, or D, 170? While shopping, you find a shirt that is marked 30% off. The regular price is $45. Which of the following is the reduced price? A, $13.50, B, $15, C, $31.50, or D, $33.75? So moving on from here, what I'm going to do is I'm going to stop the share again, share from my whiteboard, and we're going to work these problems out. So your current salary is 50 grand. Awesome, good for you. Mazel tov. So next year, you're going to get a 4% increase in your salary. So we also know 4% to be 0.04. Remember, because we moved that decimal over rather than divided by 100. But it's the long and short of it is it's 0.04. So to find the number of the percentage of increase, we multiply. So 50,000 times 0.04 equals 2,000. Well, we know that that's not going to be your salary for the next year. We have to add this number to this number. $2,000 plus $50,000 plus $52K. So your salary increase is the 2,000, but how much money you're going to make next year is 52. Okay. Which of the following is 25% of 680 pounds? So again, we've got 680 times 0.25. And I know that it's 0.25. Oh, I'm sorry. I should have done this the proper nursing mathematical way. 0.25. My bad. So we just multiply that. 680 times 0.25, 0.25 equals 170. Well, let's look at our options. We have 1,700 pounds. That's not correct. 510 pounds. That's not correct. 68 pounds, that's 10%. That's not correct. D, 170 pounds. D is the correct option. D is the correct answer. 170 lbs pounds. Okay, clear my drawing. All right, while shopping, you find a shirt that is marked 30% off. The regular price is $45. Okay, which of the following is the reduced price? So let's figure out what the reduced price is. We've got a $45 shirt. We need to find out what 30% of 45 is. So again, we multiply 0.30, 45 times 0.30, that equals $13.50. Now, that's not what the shirt, oh, come on. That's not what the shirt is going to amount to. We need to subtract $13.50 from the 45. So, how we're going to do that? Now you can just go 45 minus 13.50. You don't have to do the whole math out, because what it comes down to is $31.50. So option C is $31.50. C is the correct answer. Clear my drawing. Okay. So that basically describes in a nutshell percentage increase and decrease and understanding percentages of real world things. So let me share my screen again. Okay, apply estimation strategies and rounding rules to real world problems. An estimation is a rough calculation of numbers. The metric system is an international system of units based on powers of 10. Rounding, simplifying a number by removing decimal places or changing those places to 0. So with these math problems, we need to know, we need to be able to estimating metric measurements, knowing when it's appropriate to use a given estimation or rounding procedure, no rounding rules. So example, like rounding to ones, tens, hundredths, whatever, and demonstrate the knowledge of estimation strategies. Okay, so let's write this out. Which of the following estimates the answer to 418.6 times 3.879 over 53.7? I don't agree with the book. Let me start there. The book says that the answer is B. 400 times 4 over 50 will give you an estimate to that answer. And I understand their process with this because you can kind of do that with mental math. 400 times 4 is 1600 divided by 50. That will give you an estimate of this answer. My answer that I would go for, if I've got a calculator handy, would be A. But the book says B. So I don't know. Take it or leave it. If ATI wants you to round to the largest whole number, because that's what this is doing, so 418.6, you know, 4 or more, 5 or more, go up 1 more, 4 or less, just ignore. So we go to the next number, it's less, 400. Here, 3.8. 5 or more, go up 1 more, 4 or less, just ignore. So 3.8 goes to 4. And the same thing we do with 53. So it goes to 50. So we're rounding up to the highest number possible. That's what the book tells you to do. If that's what ATI wants you to do, that's what I do. But as I looked at this answer, as I looked at this problem, like my gut answer would have been A. But B is correct. So moving on to this next table over here, we're going to round to the place. So let's look at this. 47.38. we're rounding to the tenths. So we find our tenths, which is right here at 3. We go over 5 or more, go up 1 more, 4 or less, just ignore. Well, the answer is 47.4 because the 8 boots the 3 higher. So ones with 17 over 3. Really quickly, I'm going to stop my share and I'm going to share my tablet on the whiteboard because this is a division problem. We need to find out how many whole ones we have. So 17 over 3. You take 17 divided by 3. Whoops, not 7. 17 divided by 3. And that equals, excuse me, 5.66666666667. So we're just going to focus on, again, we're rounding to the ones. So, oops, we can just completely disregard any of the trailing 6s. We go over 5 or more, go 1 more, 4 or less, just ignore. Well, it's going to kick an extra 1 over here. So if we're rounding 17/3 to the ones, the answer is 6. Okay, that makes sense? So screen share. Okay, next one, hundredths. Well, let's look. Tens, hundredths. Eighths is in the thousandths. So 8 is 5 or more. So our answer is 6.01. Now we're looking at thousands, not thousandths, thousands. So here's our hundreds. Here's our thousands. We come over here, 5 or more, we go 1 more, 54,000. Now, hundredths, 19.796. Well, here's our tens, here's our hundredths. Come over to 6. This one's tricky because if this 6 turns this 9 into a 10, that turns it into 19.80. So it's kind of tricky how that works. So even though it rounds up to the tenths, if we're rounding to the hundredths, we need to add that trailing 0. Same thing with the tenths. 19.79, rounding to the tenths, that 9 kicks the 7 to an 8, 19.8. So it's the same number because that 0 makes the answer irrelevant. But if it's looking for the hundredths, you need to add that 0. If it's looking for the tenths, you need to drop the 0. So now let's look at the tens. We have our ones right here with our 9. Our tens is in the 1. The 9 turns the 1 to 2. We have 20. So now again, we're looking at a fraction with ones of 17 over 35. So again, let me stop my share my whiteboard. 17 over 35. 17 divided by 35 equals 0.4. And there's a big long trailing number, 857, blah, 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 whatever. So at the end of the day, we need to round to here. Well, we come over, 5 or more, go 1 more, 4 or less, just ignore. Well, it's a 4. So we drop it. If we're rounding 17 over 35 to the ones, it's 0. I hope that makes sense. Okay. So let me go back to sharing my PowerPoint and we'll move on. This is going so much faster. Okay, solve real-world problems involving ratios. So the constant of proportionality is the ratio between two quantities. Proportion is an equality of two ratios. Solve, find the answer. We need to find a proportion, set it up, solve it, and identify the constant of proportionality with ratios. Don't be afraid of ratios, guys. They're just fractions. That's all it is. Don't be afraid of ratios. They're literally just fractions. So again, pause, read the questions, write them down and how you'd solve them, and then we're going to come back and I'm going to solve them on my whiteboard. This is doing it this way. Again, I'm really glad I went through these, kind of rehashed them out, and I'm really glad I rehashed them out because this is streamlining it for you guys. You don't have to sit here for an hour and 20 minutes hearing me squawk and then flip between screens back and forth. So pause it, write them out, we'll do them together while I get a drink of water because my throat is like the Saharan desert. Okay, so stop my share here, share my whiteboard. Okay, so Micah spends 17 hours in a 2-week period practicing piano. At this rate, how many hours will he practice in 5 weeks? So they want you to set this up as a ratio. 17 hours in 2 weeks equals X in 5 weeks. So multiplying both sides by 5 weeks, because if this is a division, if we understand this as a division problem, to isolate the X, we need to multiply. So multiply by 5, multiply by 5. What that does then, so I'm going to clear this and I'm going to rewrite it. Okay, so 17 hours times 5 weeks divided by 2 weeks. So let's 17 times 5 equals 85. And then we have 85 divided by 2 equals 42.5. So if you wanted to even rewrite this out further, like I had said, you can move this to a parentheses and change the fraction symbol into division. So you can do that, or you can just change this 17 times 5, oops, 85, and then that you can do 85 divided by 2, which makes X equal 42.5 hours. That's how many hours Micah is going to spend practicing in 5 weeks if he is practicing at a rate of 17 hours in 2 weeks. Okay. Success rate for a salesperson is 1 out of 8 calls. At this rate, how many sales would the salesperson expect to get out of 32 calls? Whoops, oh my gosh. I don't know what I was doing with that one. Okay. So, again, we need to multiply both sides by 32 to isolate the X. So, let me rewrite this. 1 sale, I'm going to put an S, times 32 calls divided by 8 calls equals X. So 1 times 32 is 32. 32 divided by 8 equals 4. So if the salesperson made 32 calls, they would expect to get 4 sales out of it. Because if the ratio is 1 out of 8 calls is successful, making 32 calls equals 4 successful calls. Okay. A company found an average of 5 defective televisions for every 1,000 checked. If the company produces 85,000 televisions in 1 year, how many of them would be expected to be defective? So let's write this ratio out. It's just a fraction. Again, guys, it's ratios. It's just a fraction. So we have 5 defective over 1,000 TVs. If they're expecting to produce 85,000 TVs, we need to know how many are going to be defective out of that group. Well, we can multiply, again, multiply both sides by 85K. Whoops, that's supposed to be a K, my bad. Let me rewrite this out to show you what I mean. 5 defective times 85,000 divided by 1,000. So let's start with the top. 5 times 85,000 is 425,000. So if we have 425,000 divided by 1,000, we can just, whoops, my bad. We can just simplify by removing the number with the zeros. So 425 divided by 1 x equals 425. Now let's look at our answers. Well, 425 is there. 5,000 is way too much. 0.128 is way too much, and D4 is nowhere near enough. Or I'm sorry, C is 0.128, which is nowhere near enough, and so is D. So the correct option is A. X equals 425. Okay. Okay. Moving on. Okay, I made a drink of water. Solve real-world problems involving ratios and rates of change. So familiarize yourself with these key terms, but the whole point is that we need to define the ratio, rate of change, and determine the rate of change in a given context, formulating a ratio in a given context, and convert a ratio to a unit rate. I know that sounds like a lot, but I promise we'll break it down. It'll make some sense. I'm sorry, you guys. I don't know what the heck is wrong with me. I'm drinking like a camel. Okay. So let's move on to our, again, I apologize. I literally took this straight out of the book. For me to try to type all this out, I would have lost my mind. And so what we're also just gonna disregard question number 3. I mean, if you want to do this and do it on your own time, I think that it's great. To try to find the matching pairs of rates and unit rates would be really wise. And you can always check, Google has a conversion calculator, so you can just like literally just type in like quarts to gallons, and it'll help you figure it out, and it will show you the equation of how to do it. So, but for this time, for intent and purpose of trying to keep this short, I'm not going to do question 3. So we're gonna focus on questions number 1 and number 2. Nancy enters a fitness challenge with her friends at work. They all go walking during lunch to stay fit. Nancy decides to track her total steps over 1 month. At the end of the month, she looks back at her records and finds them incomplete. Here's what she sees. Day 3, she took 1,248 steps, 7, 2,912, 20, 8,320, 22, 9,152. Mary draws several conclusions based on her incomplete records. Which of the following is true? For every 3 days, she takes 1,248 steps, which equals for every 0.002 days, she takes a step. The unit rate is 1,248 steps over 3 days. The unit rate is 416 steps a day. The rate of change is 416 over 1. So let's try to figure out this answer. Well, we know that D is incorrect because it doesn't even tell us steps over days or anything. A is incorrect because to try to make this the amount of steps over a day won't work. The unit rate needs to have at least 1 day in the denominator. So the ratios must have units attached. So the unit rate of 1,248 steps in 3 days, although that may be correct, the unit rate needs to account for 1 day because she doesn't need to know how many steps she's taken overall over 3 days. She wants to know how many steps she's taking a day for her walk during her lunch. So if we do the math of 1,248 divided by 3, this is correct, but the unit rate needs to reflect of 1 day. Does that make sense? So the unit rate can't be over 3 days. It needs to be over 1 day. So the correct answer is C. The unit rate is 416 steps over 1 day. All right. Carl is thinking of retiring to either Flagstaff or Phoenix, Arizona. He reads in a newspaper that Phoenix has an average of 4,041 hours of sunlight per year out of a possible 4,380 hours, 12 daylight hours per day times 365 days per year. Flagstaff has an average of 10 hours and 58 minutes per day. Carl loves the sunshine and wants to retire where he will have the most sunshine every day. Which of the following expressions helps Carl decide where to retire? So 4,041 hours is more than 10 hours and 58 minutes, so pick Phoenix. Well, yeah, that might be correct, but let's keep moving on because that's not the answer that the book tells us. Okay. So these units right here, this is incorrect because it doesn't equal the same amount. This isn't set up in a proper ratio format, so A is incorrect. 4,380 hours over 4,041 hours equals 108. Well, yeah, that may be correct, but what does it tell us? That's just figuring out an equation. That doesn't tell us anything. C, again, is just another equation. It's not correct. It doesn't help us at all to determine where Carl should decide to retire and how to figure it out. So if we understand that 4,041 hours over 365 days, that equals 11.07 hours a day. So if you actually did the math on that, 4,014 divided by 365. Wait, oh, I did that wrong. 4,041, my bad. 365. That's 11.07. So we understand that there's more hours a day. There's this 11.07 hours equals about 11 hours and 40 minutes, and 4 minutes, I'm sorry. Phoenix gets more sunshine than Flagstaff, so Carl should choose Phoenix. Option D is our answer, because this actually breaks it down per hours a day and the percentage of that. So if 11.07 equals 11 hours and 4 minutes and Flagstaff only gets 10 hours and 58 minutes, Phoenix is the choice if he wants more sunshine. So again, we're going to disregard question 3. I encourage you to do these on your own to understand the ratios and their rates of change. But for time, intent, and purpose, I'm just going to blow right through it. So go ahead, pause, write it down if you want, but I'm going to move on. Translate phrases and sentences into expressions, equations, and inequalities. Equations, the mathematical statement indicates the equality of two expressions. The expression is a finite string of mathematical symbols, numbers, options, variables that are grouped to show a value. Inequality is a mathematical statement with two expressions that do not have the same value. Simplify is reducing a fraction or expression to a simpler form by actions such as cancellation of common factors and regrouping of terms with the same variable. So with these questions on the TEAS, you need to be able to define expressions, equations, inequality, write the variables for unknowns, and determine the necessary operations from contextual clues in a phrase or sentence. So, all right, pause this, write these down and write them out how you would solve them, and then we'll solve them together. So just take the time you need. I'm again gonna get a drink of water. I feel like I swallowed a freaking wad of dirt or something. I don't know what's wrong with me. Maybe because I've been consecutively talking for, oh, I don't know, past 4 hours. That might be it. I told you guys I need to maximize the time with my kids being out of the house. Okay, so I'm going to stop my share my whiteboard. Sue decides to collect postcards. She starts her collection with 7 cards. Every week, she buys 3 more cards to add to her collection. Write an inequality that would allow her to find how many weeks until she has more than 30 cards. So we know right off the bat that she wants more than 30 cards. Let me put a C there. So she starts her collection with 7 cards. And if she buys 3 cards a week to add to her collection, that's what the equation is going to look like. Let me try to fix that sign. Oh my gosh, you guys. So this is the inequality that would allow her to find how many weeks until she has more than 30 cards. So we can erase that C, but so she wants more than 30. So this is the equation that you'd have to write out. This equals how many cards she wants. This equals how many cards she started with. And this is our rate of change. Because we're trying to find out how many weeks it will take her to get more than 30. But if she's buying 3 cards a week, that's what we want to find out. Does that make sense how I set that up? I hope so. Okay, clear my drawing. Tom is saving money to go to a concert. From his part-time job, he is able to save $18.50 per week. Okay, so again, there's an indicator that shows a rate of change. So he is able to save $18.50 per week. His older brother gave him $25 to start. So we know that that number isn't going to change. He just started with 25. Oh my gosh, I hope my tablet didn't just dim on you guys. Because it dimmed on me. His older brother gave him $25 to start. So we're looking for the expression that represents the number of weeks until Tom has saved at least $235. So again, this needs to be greater than or equal to 235. So he's saving $18.50 a week plus the 25 his brother gave him. It needs to be greater than or equal to 235. Let's look at our options. Well, looking at this, option A is correct. 1850 times W plus 25 is equal to 235. Well, that's correct, but it doesn't need to be equal. It needs to be greater than or equal to. And that, although this expression is written correctly, it doesn't have the proper inequality. So option C does. And option C is the correct answer, because it needs to be when someone in a word, in a mathematical phrase, at least we know is greater than or equal to. So if he needs to save at least 235, it needs to be greater than or equal to. The $25 again is the one-time gift. The rate of change is the $18.50 he's saving per week. But he needs to have at least $235 saved up to go to the concert. I don't know what concert he's going to. That's a lot of money. Anyway, moving on. Okay, so Mary wants to take a taxi to a restaurant. She has only $20 for a taxi ride. So we already know what we're starting with. She has $20 for a taxi ride plus some change in her purse for the driver's tip. The taxi company charges $2.75 just to get in the taxi. So that is a constant. So plus the $1.25 per mile. If M equals miles to a restaurant, which of the following expressions represents the maximum distance to a restaurant that Mary can afford? So 1.25 per mile plus the 275 to get in. So we understand that 1.25 per mile is our rate of change. The constant is the 275, that's just the cost to get in. We need to know what number needs to go here. So let's look at this. So she has only $20. So she can't go any more than that. That's what she has budgeted out for her taxi ride. So this side needs to be less than this side. Less than or equal to $20. Let's see if we have that up there. Well, D is just inverse. So it has the 275 plus 125M. So this is just flipped around with D. But it's the same answer. D is our answer. The taxi charges $2.75 before the taxi even starts to move. The rate of change is $1.25 per mile. It has to be less than or equal to $20 because that's what she has budgeted to go out to dinner. Cool? Got it? Okay. Wow, that was so much faster. Holy cow, that was so much faster. This is amazing. I don't know why I didn't do this sooner. But I really hope that you guys are enjoying this. I'm going to keep hammering these out tonight. So I really hope that you're at least appreciative that I'm trying to streamline these for you. And again, I hope that you're gaining something from this. So thanks for joining me. Look for the next math installment. This will probably be the last one of math for the night. So yay, mazel tov. See you later. Bye.